This introductory module comprises of a free demonstration. We shall be conducting a realistic test flight on a simulator. We'll be extracting data the way we do in test pilot schools. Python basics such as installation, importing the data on Python, explain basic data manipulations, and conclude by bringing out some plotting functions. So these are all the topics which we'll be covering in this free demo. The demonstration flight was conducted on a simulator using L39 Albatross module. So we'll be taking off. We'll establish a climb. Level out at an altitude of around 10,000 feet. Initiate a stall. After establishing the characters of the aircraft in the stall, we'll go for a spin. During spin, we'll be losing around 5,000 feet. Thereafter, establish at 5,000 feet altitude AMSL. Establish aileron rolls, full deflection left and right. Followed by a rejoin circuit, and we will do a roller takeoff again. Again establish a circuit pattern and come for full stop landing. The advantage of adopting flight test demonstration based approach is that test crew will be able to relate Python programming to their domain. Our main focus will be to teach with respect to flight test requirements. Keep it simple and easy to grasp for test pilots and flight test engineers who predominantly are not from software background. After having completed the test flight on the simulator, now let us look at how the data is looking like. So this is how the data from the simulator looks like. Just very familiar to something what we do in test pilot schools. All parameters of interest such as indicated airspeed, TAS, mark, pitch, roll, the control deflections. So almost 40 to 50 parameters have been extracted from the simulator. When you're adopting Excel-based data analysis, what you'll be doing is you'll be choosing a particular column, plotting it, and see. So in this case, I'm just seeing how the indicated airspeed is varied with respect to time. So we'll be doing this for plotting angle of attack against time. So here you can see how the angle of attack is varied during the stall and spin. Similarly, I'm plotting the variation of indicated airspeed against time. So this process is very laborious, time consuming, and repetitive. So there's plenty of scope to automate this so that you can focus on the real business of flight testing and spend less time wrangling with the data. There are plenty of YouTube channels which explain how to install Python packages. We recommend installation of Anaconda distribution. You need to visit the anaconda.com site and download the Anaconda distribution for Windows. So you will get a exe download. So download it in your computer and install. In case of any difficulties, you can refer online help videos which explain step-by-step process of installation of Anaconda distribution. After installation, go to the Windows start bar and type in Anaconda and open the application. So it takes some time to open depending upon the configuration of your computer. So it opens up like this. So all the inbuilt applications inside the Anaconda navigator will be visible to you. So all common Python IDEs such as Jupyter, spider, and PyCharm are available. So throughout this course of this instruction, I will be using spider. I find spider as the most suitable for flight test requirements, primarily because it has the environment which resembles close to that of Matlab. This is how the spider IDE looks. So you've got three major partitions. On the left is called the editor, where you will be editing the code. To the right top is the variable explorer and the area where you can see the variables and also plots. The bottom left is called the console, where you can type in your code line by line and check the output. So here is the basic hello world application which I am typing on the editor. So it's as simple as print within quotes hello world. So you will have the hello world output which is coming on the console, the right bottom. So you can also type print hello world either in the editor or on the console. So if you type in the console, you do the same thing, print hello world within quotes and enter. So you will have the output hello world immediately coming up after you enter. So I'm assigning a variable here, A, some value, and also B. So which you can see that I have assigned it through the console, and also you can see that the same thing is reflected in the variable explorer. So I'm saying C equal to A plus B, and I'm printing C. So this is what I have done step by step in the console. Now we will do the same thing on the editor. So what we are going to do is we are making our first Python script. So I'm clearing it. I am clearing the variable explorer. Now all the variables which are stored are cleared. I'm starting A equal to 5, C equal to A plus B. So I'm printing the value of C. So this is a small script which is written, and to execute it you need to press the play button here. So the script has been executed. Now the output is being printed, and after that I'm saving this script as a .py file, which is hello world application. Pardon me for the spelling mistake there. So here what we have done is we have made our first script and stored it in a location. You can see. So this is the .py file which we just made and saved it here. So you can also open in the notepad. You can see that I have assigned A, B, and assigned an operation for C, and then printing the output. All right. So now what we can do is I've closed the spider application, and you can also open the spider application independently through the Windows menu. So I opened the spider through Windows. So again, the time taken depends upon the configuration. So here I'm opening up the Python script which we just made called hello world. So I'm opening it. All right. Now here is a Python script. So there's something called read directory and write directory. So I'm also giving the path of the write directory the same path as the one which I gave for the read directory. So I'm going to run the script now. So it's run. See, the output is printed, which is seen on the screen. Let's get back to the flight test which we did. So we had undertook one complete representative flight test profile in which we had flown certain test points, and shown here is the Excel file which has all essential parameters which is required for us to do the flight test data analysis. The objective of my tutorial here would be to demonstrate how we can process this flight test data using Python. So what you do is you open up Spider the way I had explained it before. So you create a new editor file. So here you have a blank editor to your left. So what I'll be explaining is how we can write a code. What we are going to do is we are going to write a small script which will take the Excel file and then we will demonstrate how we can process the flight test data. To begin with, you need to import three important libraries on Python, which are pandas, numpy, and matplotlib. So these are the commands for importing. Import pandas as PD. PD is the alias for pandas. It's a widely accepted alias. PD for pandas, NP for numpy, PLT for matplotlib.pyplot. I'm sure you are wondering what these modules mean and what are the functions. In this tutorial, I'll be covering it briefly. Detailed explanation for each of these libraries are coming up in the subsequent modules. Pandas is a fast, powerful, and easy to use open source data analysis and manipulation tool built on top of the Python programming language. As of now, you understand that pandas will be required for you to work on any Excel-based dataset. Numerical Python or NumPy is the fundamental package for scientific and mathematical operations in Python. Matplotlib is a comprehensive library for creating static, animated, and interactive visualization in Python. So we can make plots using Matplotlib. Matlab differs from Python in many ways. In Matlab, you have all these functions which are inbuilt and are available always, and you can call them anytime in your code. However, in Python, you need to specifically import the functions which you will be needing it. And these functions are generally given aliases, like pandas is given an alias as PD, numpy as NP. So you need to call these functions wherever you need in your main code. The first task for us is to import the Excel file. So what I'm going to do is I'm going to demonstrate how you are going to import the Excel file which consists of the flight test data. As I had mentioned before, you have a read directory and the write directory. The read directory is already chosen, the path which consists of the flight test data. Here I am choosing the write directory also with the location where we have our flight test data. So primarily the import, like you need to import your Excel file from the read directory, and the output of this code will go and get stored in the write directory. So now the first task is we need to import the Excel file for which the code is data frame. So data frame, we give a short form as df equal to pd.read_excel. Within quotes, you give the exact file name of the Excel file. Here it is L39_flight1.xlsx. So this is a single line of code which is used to import the Excel file onto the Python. So care must be taken that where you have stored the script the location should be the same. The location of the script and the Excel file must be same. So if it is not same, then it will throw up an error that file not found. So in this case, we have the Excel file and the Python code in the same place. So after I'm running it, it is processed, and in the variable explorer column, you see one variable which is formed by the name data frame. So you can see df, type is data frame, size is nothing but the number of rows and columns. So you can see it is displayed now in the variable explorer. Once you open it, you can exactly see the way you are seeing an Excel file. All the columns and the rows are populated. If you have to check whether the Excel file has been imported properly, you can type in df in the console and enter it. What you are seeing is the first 5 rows of the file and the last 5 rows are displayed here. So remember, when you type df, that is the variable name, you will not be able to see the complete Excel file. You will be seeing only the first 5 rows and the last 5 rows of the data frame. If you want to see the details of the columns, the column names, so you need to type df.columns. The moment you type df.columns and enter, the names of all the columns will be displayed. If you want to see the first 10 rows of the data frame, you type df.head within bracket 20. If you want to see 40, just type df.head within brackets 40. So you will see 40 rows of the data frame. So often you may need to check the column names, so you can again type df.columns and get the details of the column names. Now I'm going to explain how you can extract one particular column from this data frame. Now that you know the column names, say if you want to extract angle of attack. Here what I have done is I have named the angle of attack column as alpha. So the variable name is alpha equal to df within square brackets and quotes AOA. The variable explorer will give the details of all the variables which we have invoked in this code. You can also extract the columns using column index. So here I have assigned a variable called time using column index. Time equal to df, I opened the square brackets, colon, comma, 1. We have checked how to access a column using column name and column index. You can clear the console by clear command. Now that we have understood how to extract a particular column, now I am going to demonstrate it on the editor. So we are converting all these commands into a code. For any data analysis, we need time. So here I am defining time equal to df within open square brackets and within quotes command. We need altitude. Similarly, I am extracting the altitude information from the data frame. AGL, that is altitude above ground level, is the altitude of interest for me. IAS, indicated airspeed, I'm extracting using column names. So I'm extracting the columns based on names. Ensure that you give the exact name as it is appearing in the data frame column. Any spelling mistake will throw up an error. Don't forget to mention the df. So df is the variable which we are given for the data frame, and calling the corresponding column name will assign that particular column to a variable. I'm removing all the variables. Now there's no variables which is stored. So there's a small 5-line code where we are calling the data frame. We are assigning one Excel sheet to the data frame called df and extracting each and every column of time, altitude above sea level, IIS and angle of attack. Assigning each of these to variables called time, altitude, IAS and alpha. I'm running it. It takes some time to run. It's almost 40,000 rows. Yeah. As you can see in the variable explorer, you have the variables created for data frame, alpha, altitude and time. You may want to check whether the variables have been assigned properly, so you can come and type in the console. This is how you can import an Excel file, extract the column of interest and store it as a variable. Now that we have seen extracting columns, I'm going to teach you how to plot it. Plot function is nothing but plt.plot within brackets, you give the variable name. Here I have plotted altitude. Next I'm interested in alpha, and then we are plotting IAS. So this is a bare bone plot without the x-axis name, y-axis name, grid functions. So all these will be taught in the subsequent modules. One major issue with flight testing is after the completion of the flight test sortie, you will get a huge data set which you may need to segregate as per test points. So in a conventional sense, in Excel, how you would be doing is you will be plotting the one variable. So in this case, let's say I'm plotting the altitude. So you know that you have done some test points at 10,000 feet, you have done some test points at 5,000 feet. So what you do is you go and then you plot it. From the altitude plot, you can understand that after takeoff, you have initiated climb till around 10,000 feet, initiated a stall. Thereafter, we have done a spin and some test points. The first task for the flight test crew is to break down this complete Excel file into test points. So it's a very laborious task when you do it in Excel. Now I am going to teach you how you can slice these data frames as per test point. Let's say you are interested in takeoff. Seeing this altitude graph, I can tell you that so this graph is nothing but the index numbers of the rows on x-axis and the altitude in feet in y-axis. You can see that the takeoff is somewhere between 0 to 2500 index numbers, that is the x-axis. So all you need to do is you need to define a new data frame. In this case, I have defined a data frame df underscore takeoff, in which I'm going to slice only the data pertaining to takeoff. All right. So here it's defined df underscore takeoff is equal to df open bracket, open square brackets, 0, you give a colon, and then 2500. So what this is going to do is it is going to take out the indexes from 0 to 2500 and store it in a variable called df underscore takeoff. You can see in the variable explorer that a new variable is formed which is called df underscore takeoff, right? I have run it. Now you can see in the variable explorer, df underscore takeoff is a new variable and I'm opening it. So this has all the column values, but only the index is restricted to 2500 maximum. So what we have done is we have sliced a portion of the main data frame which had almost 40,000 rows, reduced that to 2500 rows, and this particular data frame has only takeoff data. To cross verify it, I'm going to plot the altitude of the data frame underscore takeoff, that is df underscore takeoff. You can see that the number of rows has been clipped to 2500. Now that you have sliced a portion of the data frame to make a separate data frame for takeoff, that is df underscore takeoff, now you want to write an Excel file which only has this takeoff data. What you do is you give a command df underscore takeoff, that is the data frame variable name. You mention that, and then the command is dot to underscore Excel. So this command to underscore Excel is for writing the data frame variable as an Excel file. And this file will be formed in the same directory from which we had accessed the input Excel file. Let's see what happens now. So I'm going to run this command df underscore takeoff to Excel. You can choose the name which you would like to give for the Excel file. So in this case, I have given of this sliced data frame, I have given L39 underscore flight 1 underscore takeoff. So this is the name of the new Excel file which I have made exclusively for takeoff. I've run this file now. Let's see what has happened. There you go. So there is one Excel file which is newly created with the same name, that is L39 underscore flight 1 underscore takeoff, in the same directory from which we accessed the main Excel file. I open this. What we have done is we have sliced the main file into a subfile which has only the data of takeoff. So as you can see, you can plot it and see. So only 2500 rows are available here. This way we can keep slicing the parent Excel file into small test point files. For example, I am taking out the landing data here, that is creating a new file, or I'm creating a new data frame, df underscore landing 1. So we have done two landings. One was a normal landing, full stop, and the other one was a roller takeoff. So what I've done is I have made, using the index numbers, I have made two different data frames which are going to give me the data pertaining to landing. After taking the data frames for landing, I'm converting that into Excel files and writing it in the same directory. As you can see, the directory which initially had only the L39 main flight data is now added with 3 different Excel files which has been sliced by us using Python.